Okay, so why don't we start? And it's always fun to be in the company of some very powerful person. And you know that Dr. Ramachandran is able to take my entire career and encapsulate it in one single graphic. And that's basically all I've done, what's in that graphic, right? And it's kind of exciting and scary all at the same time. So that's the kind of thing we're going to talk about, and whether the dream I was fantasizing about in that poem of having a living book that could update itself, whether that's a ridiculous fantasy that will never occur in the history of the world, or whether that will become a common thing in the future. And there'll be many living books where it's a background database, and that database is automatically updated, and so the text of the book is updated. Okay, so Dr. Ramachandran, why don't you take over leading us? And when
Yeah.
you're ready, you can show the slide set.
Okay.
Yeah,
So I start sharing the screen.
okay.
Oh, it's a desktop that should appear, isn't it? Can you see my slide?
Yes, yes, we can. That's great.
Okay.
Excellent.
Okay. So now probably you should be able to see better.
Yes, yeah.
Yeah. So, um, friends, I'm going to take a slight, I mean, short tour here on a question that Kim had asked me a few months ago. So I am also new to this. I have not ever thought of working along these lines because in our institute we are mostly busy with genes and genomics. So this line of question was never asked in our institute. And when Kim asked me, I was a bit wondering that this looks like a surprise and could we do it? So I took that chance to embark upon this, and now Kim offered a opportune moment for me to share this experience with you. So the title here is on how PubMed data mining algorithms can depict subspecialty author networks and help connect the past to the future. So it's a tough title, I must say. He gave me the freedom to choose my own title, but instead of doing that, I thought that let me work on this title and see what best I could do. So, moving on, the first is uh, Kim's questions that he asked. So, in short, he had some experience with many other softwares and he was making these networks himself for quite some time. And then he approached me to generate data for 2020 here, which is in a way it was asked to compare with the 2012 network, especially for the Banff uh, transplantation classification. That was the main focus. So he said that it would be wonderful to create such a network graph for 2020 and whether we could help him with that. So the key terms are Banff and transplant. It's a specialty in medicine. I'm not a medical person, but I learned something from this work. So I'm very happy and thankful to you, Kim, for asking this question.
Great.
So moving on, this is the network Kim sent me uh, in his email while approaching with the question. And you can see here basically network of authors and the connections between the names of the authors. They depict collaborations between them, meaning that they have collaboratively worked together on some idea to accomplish some common goal. So you can see there are many collaborations that has happened, and this is typical of the scientific field these days. What was interesting to me in this picture, you might also notice, is that there are sub networks. You see, islands of networks which are not connected to other names. So there is a Chapman network at the top. If I can show through my mouse,
Yep.
this is the Chapman network, and this is the Japanese network, Takahara, Kyo, Okuyama, and Kokado. This is the Japanese network, and you see there is no connection between Japanese network and Chapman network. So they are working as network in different countries. Uh, Most likely, that's what it is. And I want to show you more about this. Then you can see this big network here where Soles himself appears, Kim himself appears, and then along with many other authors, they work in collaboration together. And the lines here, they depict, the dark lines depict more collaborations, and the lighter and dashed lines, they depict lesser and lesser collaborations, and so on. So it's a kind of a weighted network that Kim has prepared, and he used some algorithms and prepared this. And what had happened was he couldn't reproduce it with that, with those softwares, ran into some technical issue. So then he approached me. So what did I do? So first, we tried to understand what Kim did and what he was trying to look at. So we used the same keywords of search, Banff and transplant in PubMed, and we took the summaries. So the PubMed is very beautifully organized. So for this kind of work, you take the summaries, not the abstracts. So if you take the summaries, they offer a Excel kind of table. It's a comma separated values table. And then you can sort by the top authors, then pull out the co-authored papers, which are basically the collaborative papers. And then you draw the networks using cytoscape. So when we do this, you can now see this slide of network. Uh, have you Are you able to see this network now?
Yes. Yes, we
Yes.
are.
So you can once again see that there are sub networks and there is a large network in the middle. Okay. Um, it is, we have moved around the nodes and edges a little bit. We have not tampered with the connections, but we have moved around the nodes in order to improve the clarity. And we can see here that the same Japanese names appear, and Takahara Kyo that were there in Kim's network. Then here is Kim's name with Dr. Mengel and many other authors in this large network here. And there is another network here of some authors. And then there are also other small networks of collaborations, authors in this area. You can also see that some lines are thin and some lines or edges they are called, they are thick. So these thick edges means high level of collaborations, and thin lines or thin edges means low level of collaborations. So we could reproduce this network, and Kim was satisfied with this.
Yes.
And then what I'm going to show you today is a little more detail on this aspect. So if you look at carefully and map these names of these authors to different nationalities, which is what the first thing I could think of, and maybe others would also have thought of the same. I could see that this is the Japan network of people. Although these are Japan network of people, there are two networks. One is a sub network of the other. And then we have this large network of people from Canada, USA, Europe, based on their last names, use of last names. Then these names, which appear here in this network, they are like Spanish names. So all people from Spain. So now the question that came to my mind is that why they are these sub networks, different networks? Are they doing different things, or are they simply working together because of their cultural similarities and nothing else? So, in order to look into that a little more deeper, so I tried to do some data mining with our programs. So you can use the PubMed in any way you like. You can use the author names and prepare uh, sub papers belonging to these networks, and create what is called a picture of what is their most trending research in that author network. So this was done with this PubMed Miner package, which is available in R. Anybody can use it. And now here we have the authors from Spain network. So that's what Kim was talking about. All the publications represented in one picture. Uh, this is actually using a word cloud of the top 50 terms of papers from Spain. So you can include more terms or you can include less, but 50 seems to be a reasonable number to start with in order to show trends and patterns through which we can understand what are these authors and what is their focus. So you can see that there is biopsies word is coming as a dominant word here. Patients, of course, will come. Then it's all about renal and kidney regarding that mostly. And the word rejection is important. And you can see Barcelona because that's where this research has been going on mostly. There are also other terms like chronic and transplantation, nephropathy, and so on of medical significance. And this is how we can more or less get a view of the Spanish authors' collaborative network work in Banff transplantation. Now let's look at the Japan network. So the Japan's authors network, we had the authors, and naturally Tokyo comes in the dominant position now because that's where the research has been going on. And then The dominance is again there with respect to rejection, that is the rejection of transplants. And that has been the focus of the research. And I'll show to you what type of rejection they are talking about in the research, and all through computer algorithms. You can see one word, antibody hyphen mediated. That's a uh, clear factor important in rejection of the transplants. So these are isolated words, they do not really show the context. So we can only get a broad overview from them. How to get the context, that I will show you in a couple of slides later. But more or less, it looks like the Spain authors' research and Japan authors' research is more or less along similar lines. There may be some differences in the details, but if you look in the overall picture with the terms, they look more or less quite similar. This is what I feel, I felt. Now, within the Japan network, we saw another network, which was a smaller collaboration between Takahara and Kyo. And their research is from Osaka. So that's coming as the dominant part here. You can also see the words Banff and transplantation. Now, here you can see deposition is coming a little prominent, more than rejection. Rejection is also there, but comparatively, the word deposition comes as more prominent. Is it the reason that this network is isolated from the Japanese network? This could be one reason uh, among the specialities. Now, let us look at the uh, Solis Authors Network. I am, forgive me for using your name here.
That's
I
okay.
want to give some name to the network.
Okay.
This is a network of many authors, a very formidable network of collaboration, and is indicative of some very good science emerging from there. So you can again see the focus has been on rejection, the rejection of the transplanted tissues and so on. And then there has been focus on allograft and a few others with some little details. There is some difference with the Spain network, but overall it is quite similar to the Japan network and the Spain network, and a kind of little different from the Takahara Kyo network. Now we can go into a little more detail of this. Among the top 50 terms, what are the common terms? What is the proportion of the common terms between the two networks of papers? So we see that between Spain and Japan, it's about 21 by 50, that's about 42%. Similarity, the similarity between Takahara, Kyo, and Japan is a little more, about 50, 25 by 50, that's about 50%. But when we come to Takahara, Kyo, and Spain, then there is a dramatic drop in the commonality between the terms. Many of these terms are actually medical terms, so they have proper meaning. So you can see that it's only 12, indicating that the small similarity between them. What is interesting is that if you look at these terms, the terms Banff, transplantation, biopsy, allograft, patient's rejection, this is basically the trunk of the research of Banff transplantation. And in that trunk, there is similarity between the Takahara Q and Spain, but later on they diverge in, in their focus. So that's pretty interesting, and that might explain how groups of authors they work together in a network, little bit apparently looking that they are separate from each other, even though they are all in the same field, Banff transplantation. Now I can use this uh, proportionality of the common terms between the different network groups and draw another graph. This is like a meta graph, if you will, between the different authors' networks. You can see the very thin edge between Takahara Q and Spain groups, but between other groups, the edges are quite thick, meaning that there is very good similarity between their works. So the Solis group, the Japan group, and the Spain group. So one side of this geometrical figure is rather thin, but the rest edges are quite strong. Now, if we want to look at certain unique terms which are coming prominently within the top 50 terms, and we saw that Takahara Kyo was looking a bit away from the others. Now, let us compare them. Let's say, for example, with Solis network. Then we see that the focus on Takahara and Kyo has been on deposition. What type of deposition? It's immunoglobulin A deposition and C4D deposition in different tissue areas, their identification and their studies. And whereas on the Solis and other authors' network cases, including Japan network also, it is on the antibody mediated rejection and T cell mediated rejection of the transplants. Now, it is not that uh, the Solis groups and others, they have not focused on deposition at all. They, yes, they also talk about deposition. But in terms of the paper's focus, if you look at it, the proportion on focus on rejection has been more in this side compared to the Takahara Kyo group. So to this extent, we are able to learn from the computers. Now, moving on, we wanted to, Kim had proposed this idea of connecting to the future. So I thought the best way to look at this is to see what the authors themselves think about the future and have they reported that in the papers. So by looking at the future word present in their uh, papers and in what context they have mentioned, we can see very readily the Banff Foundation for Allograft Pathology, which is being developed, and how it is going to be updated from 2019 onward, the way the future thoughts they are thinking, the emerging research on collaborative working groups addressing issues like isolated V and incorporation of omics technologies, which excites me even more because we are into omics technologies. And now, this is the key thing that is in terms of future advancement that they are proposing is combination of graft biopsy and molecular parameters within the Banff process. So that gives, that clearly is a step forward in the future where we might get more details worked out on this area. Then the molecular diagnostic criteria into the classification. Then antibody mediated rejection prognosis marker and treatment, and the collaboration with Human Cell Atlas project, which is upcoming technology. So what they are doing is that they are trying to connect Banff transplantation, classification, and enriching it, expanding it, giving it a more future shape by trying to connect to these modern emerging technologies. So this is most probably how the future thoughts and future is going to emerge. So it looks like more and more precision is going to be added to medicine through these technologies. This is a feeling I could get from looking at this data. And the combining histopathology and molecular parameters is going to be the uh, future in this area. Now, not certain very what I could also note that this type of future thoughts was not coming from the Spanish or Japanese authors networks. They haven't mentioned any such thing in their papers. So I was wondering why. Why is that so? Is it because that the Solis network is a big network and therefore allowing a lot of people thinking together is actually helping cooperational thinking in order to look at future in a better way. Small collaborations is focused on certain specific tasks only, and possibly it is not leading to launching onto higher future. Is that the reason? It could be. That is something as a matter of thought that I could learn from this. Now, we have learned some of these things from the Banff transplantation process. The question that came to me is that is there some common principles or some common rules that we can derive from this, and is it applicable in other disease or other cases of medicine also? So I tried to explore a little bit on the diabetes mellitus condition. So this is the top authors networks of diabetes mellitus. So here we can see once again the different authors networks. So one is this big network of Zemet, Alberti, Lefebvre, Lamarck, and so on. And then there are some other authors. Here the node, bigger node means they have more papers. And thicker connection means they are connected more strongly. And one, this connection is a little bit awkward in the sense that it's the same person. It's the same person, but somewhere he's using his middle name, somewhere he's probably not. He's not using. So that is that apart. Uh, this seems to be a network that is quite strong, and you can also see the American Diabetes Association is connected through Skylar. And then these connections through other authors are very thin, meaning that there might have been just a couple of papers or so between them. Then there is another network, which is the Mohan network here, which is from India actually. That comes at the top. So I was a bit curious. Okay, so let us explore this further using the computer algorithms. So once again, we can create this word cloud network of the top 50 terms from the diabetes papers from Mohan Authors Network. Uh, and you can see the diabetes word comes at the top most prominently. India comes, which means the location comes very nicely. Chennai also comes. That is the city where Mohan is doing their research. So these terms they come out very nicely. And in addition, there is mention of risk, uh, glucose and insulin, and hospital and subjects and so on, which is the typical medical study here. Compared to that with Zimet Authors Network. So in Zimet Authors Network, now here you can see certain terms are coming little more differently in prominence. And this work is coming from Australia. You can see the mention of Australia. And the words diabetes is prominent, no doubt, which is what it should be. Then there is insulin and glucose, a lot of papers they discuss about that, which is still a primary treatment for the diabetes condition. And then there are mention of other terms in this area. Now the question that arose is how this is different from the Mohan network. Is it different subject wise? Is that the reason why these networks are different, or the focus is different? So I looked at the commonality between them, and there is very high commonality actually. There's 32 out of 50 terms are common between the two, indicating about 64% commonality, which is pretty good considering the diversity in the papers that is usually published in these areas. Then looked at the, sorry, 1 minute. Then I looked at the future thoughts from the Zimet Authors Network. How are they thinking about the disease, managing the disease, controlling it, and so on? They mention different focus compared to the Mohan network. And that's where the difference is striking. So, if we look at the Zimet Authors Network, there is mention of epigenetic modification in early development of the baby. And that seems to be an important uh, factor to be considered. Young onset TDM, at very young age, many people are now getting type 2 diabetes. Now, in terms of care, what is to be looked at is whether nurse implemented health care or a standard care. Ethnicity, then health promotion campaigns, which is required for controlling the disease so that people are aware of it and they take measures to control the disease. The cost burden, because of micro and macrovascular complications. The the point that about diabetes is that as long as you have T2DM, which is type 2 diabetes, only it can be somewhat reversed, meaning that through controlling various parameters, lifestyle, and so on. But when it enters into micro or macrovascular complications, such as kidney disease or retinopathy and so on, then it is not possible to reverse it anymore. So you enter into a no coming back kind of a stage. And that's very dangerous to the health of the person, because from there the cardiovascular events start to have very high probability of occurrence. So the health cost that is involved in managing these conditions. So this is an important parameter to consider. So people should be diagnosed earlier and controls should be implemented earlier so that they don't get into these stages. Now, what is in terms of technology, what they are thinking, the thoughts are going is in terms of lipidomics risk score, cutoff of fasting plasma glucose. It is being lowered now. It was 140 milligram per DL. Now it is reduced to 126 or something like that. Then high leptin, uh, mild retinopathy, detection of that, waist to hip ratio. These are measurements that should be focused on in order to, that's what they are proposing. The authors are proposing for controlling the disease. If we look at the Mohan Authors Network, they are also looking at controlling the disease, but the focus is on biomarkers based on omics technologies, diabetic retinopathy, which is common between both the groups. In fact, the world over is thinking about it, and low adiponectin, which is different from the Zimet Authors Network's focus. 1 hour post glucose measurements, lipid metabolism, a bit commonality is there. Then rhamnose enriched polysaccharide in order to prevent it. Then telemedicine, M health using smartphone and access to rural areas. So these are focuses which are unique to the geographical conditions of these countries, and therefore the future, the way Mohan network thinks, and the future, the way Zimet network thinks, they are different, and that's where we see the differences. Moving on, how authors collaborate. So I came to that very fundamental question. And so I drew up these patterns and attributes all from this work only. So you can see nationality and cultural attributes. That is very clearly coming as prominent. No doubt about that. Now the question is, if science is universal, then why this should matter? Because science is same, whether it is a Spanish person or whether it is a Japanese person, it doesn't matter. Science is universal. However, when it comes to collaboration, there is some link and affinity, cohesion of people belonging to common cultural attributes and nationalities. Then the second thing is proximity. So proximity appeals. Okay, he is there just 1 hour drive away. So it is easier to collaborate. It's a very common place to think that way. But really, does it matter? Today we can call, we can join through Zoom. We are separated by more than 10,000 miles, and we are talking like as if we are next to each other.
Yep.
So, does it really matter in this technology era, proximity? But, but when it comes to collaboration, proximity still matters. So, this may be a little bit old thoughts still prevailing, and what we can see is that in future maybe these trends will change. Now, if we look at how we can use computer algorithms for um, changing or increasing the collaboration networks or expanding them. So we can think how AI can help here. So AI can help in alignment of thoughts. So these thoughts, data which I extract from the author's papers, they can be used to train AI engines, which can then put the thoughts together and say that, okay, these are the people who are thinking together. So maybe they can work together also. The second point is on style. So all of us communicate in English, but the style of communication of a Japanese is different from the style a Spanish person communicates, which is different from the style a British person communicates, and so on. This style can be captured by AI, and using that, it can do this, help us in style matching. And that can again help in fostering more collaborations. Mutual benefits. So every collaboration looks for benefits, and that what kind of offers uh, can a particular author can make vis-a-vis another author, and that AI can again give in terms of the strengths and capabilities between the different groups, which can help us in building new collaborations. So what people will do manually by looking, understanding, talking, and so on, now AI can help using this data. AI can help suggest for many different possible collaborations. Of course, whether actually it is implemented or not is not uh, under control. It's controlled by somebody else, the funding authorities, and so on. But at least the AI can suggest these possibilities. This is what I could see in future. It could be happening. So, in the end, I wanted to focus on this particular point of 10 simple rules of collaboration written by uh, Vicens and Phil Bone. So, you must have come across this paper in close computational biology some time ago.
Yep.
The rule 6 says communicate, communicate, and communicate. So, we have to identify what are the facilitators of communication. Like Zoom is a facilitator of communication. And then what are the barriers of communication? So we have to somehow tackle the barriers and enhance the facilitators. And towards this, the AI can help us in terms of building communications between different people and authors networks. Now what is going to happen is whatever network we saw is going to become stronger and stronger. That is quite natural because those networks got developed because of repeated collaborative works between the different scientists. So that will get more strong through AI. Those which were weak will possibly get enhanced and become stronger. Underneath, we also have to remember that some people have not been successful in bringing about multicultural collaborations whenever they tried to. The question that arose in my mind while working through this short work is that maybe AI can solve that problem. Maybe AI can turn it around. Then we will see a different world altogether. So with this, I sort of this is what I wanted to present, and this
Great.
is my last slide. So I'm now open for discussion and questioning, and let me know your thoughts.
Yeah, if you could stop sharing, then we'll be able to see the students and
Yes,
that will work better. Yeah.
yes.
Okay, so any questions, guys?
Yeah, thank you, Dr. Ramachandran, also for being up so late.
Yeah.
Meet with us. I have a question about the way in which you think AI can help in collaboration. Do you suggest that artificial intelligence systems could find groups that are working on similar topics and then suggest a connection?
Yes, it could not only similar. So it all, if you like, for example, if you look at the Solis network, for example, they are not really into similar things in the sense that they want to keep their field focus as Banff transplantation. That focus will be there, but they want to enrich it and expand it further. So if they have to do that, then they have to collaborate with other specialties like Cell Atlas project or omics technology or so on. So now AI can suggest, based on its experience with omics and based on its experience with Banner, that what can be the nearest point of connection between these two groups. So that's what I feel, and that can come through some of these parameters, which might include proximity, which might include nearest place, and so on.
Thank you.
So other questions? So the idea of a graphic that would automatically update itself or a book that would automatically update itself, is that something of this decade, this century? When will that become common, or will it never become common? Is it just the strange Kim Soles idea that will never ever happen in the history of the world?
I think that it is very much possible because the computer is, the algorithms have now become so precise and powerful that it can extract the data and it can pull out these graphs and it can show you the differences. But the point that I was facing is that when do you begin to see the difference? So you may, if you see every day, then you may not feel the difference because it's coming very slowly.
Right.
Yes. If you see it in increments, then yes, you can feel the difference. Oh, this is what has come. Okay.
We have talked about this in that the future will arrive so gradually that we won't even realize it's here.
Yeah.
And in a way,
Yes.
I
Yes.
wonder if that book that updates itself is not already here because the internet in itself is a book and
Yeah.
or plays the function of a book, and the information is available already over there. It's just, I feel that there's not one single place where we can find information. It's scattered everywhere, and that's why it's so difficult to find it. But I guess that if we create a single place, a database where well, like the NCBI is one of those, then it's easy to find research for the field
Yes.
I work in that particular database. So
Yes.
in a way, I wonder if we won't shift from books towards screens because we're already doing it. And if that book you're talking about, Dr. Soles, is that
Sure.
internet that is already here.
Yeah. Yeah.
Yes.
Okay, well, I have another meeting, but thank you very much, Dr. Ramachandran. I think this has been very productive and it exceeded my wildest hopes for what we could accomplish in 1 hour. And the students, are very busy. So they're in the midst of, exams and final papers and everything. So I'm grateful to them also for coming and participating. So that's great. So we'll stay in touch. We'll do this again. We will build on what we've already created together and do great things in the world, eh? Okay.
I actually have one final question if you have a few minutes.
Sure.
So my question is on AI pets, so robotic pets. And I was wondering what the guest lecturer, sorry, I don't want to pronounce your name wrong, what your thoughts are on kind of the integration in people's everyday lives, and will robotic pets, AI pets, ever be able to replicate that of a real dog or a real cat, anything like that?
So I've just purchased the Sony Aibo robotic dog for 2020. I think I'm the only person in Canada that has it. So that's part of where that idea comes from. So what are your thoughts? Will robotic pets become even better than real pets? Now, Eduardo has a lovebird. It's not here today, but usually it's on his shoulder. It's a very important part of his life.
I know for one thing that when the robotic pet falls sick, I have to go to a different place.
Yes.
The real pet has to be a different doctor.
Yeah,
So I know that's a difference.
that's right.
That's a difference. So I think we probably should not disconnect from nature. We should be connected with the nature as because nature offers a lot of beautiful things. The birds' songs and the birds' behaviors, the squirrel, how it jumps and wants a biscuit from me every day. It comes early morning. It
Yeah.
knows the time. I don't know how it knows the time, and it then how the doggy will come and say its hello in its own way. I want to enjoy that. I want to enjoy that. I want to use AI only to the extent that certain deficiencies in us, certain weaknesses in us can be overcome for the betterment of our life and culture. Uh, that's about it. I want to enjoy the real dog.
Yeah. Okay. Well, that's a wonderful answer. Okay. Well, that has to be the end of this. So thank you very much. We'll do it again. Thank you for participating, and thanks to the students
Yeah.
also. Bye bye now.
Great
Bye.
talking to you.